Hello everybody, this is Amadou Jallo and I am a student of Material Science and Engineering, and I'm going to use this platform to demystify Material Science and Engineering to my friends and family, to make us understand Material Science and Engineering and the importance of Material Science and Engineering in our daily life. So I'm going to start with Material Science and Engineering. I'm going to use this book by William D. Callister Jr. and David G. Redwish. This is the introduction of Material Science and Engineering and the 9th edition. Like I said, this is the 9th edition. This is the Material Science and Engineering and Introduction by William D. Callister Jr., Department of Metallurgical Engineering, the University of Utah in the United States, and David G. Redwish, Department of Chemical and Biochemical Engineering, University of Iowa. Next, we move to the content. So briefly, we're going to start with the introduction, learning objectives, the historical perspective, material science and engineering, after studying material science and engineering, and why study material science and engineering, and case studies. We're going to look at the classification of materials. Okay, then we're going to move to the chapter 2, which is the atomic structure and interatomic bonding. Then we're going to look at the chemistry side of material science and engineering. We're going to look at the atomic structures in more details, the fundamental concept, electrons in atoms, the periodic table. We're going to also look at atomic bonding in solids. We're going to look at the bonding forces and energies, primary interatomic bonds, secondary bonds or van der Waals bonds, material of importance. We're going to see mixed bonding, molecule, bonding types, molecule classifications, all this. And for chapter 3, we're going to see the structure of crystalline solid. There we're going to start going deep into the material science. And for chapter 2, we deal with the chemistry side of material science and engineering. And here we go more details, the structure of crystalline solids, so we can see crystal structures, what are crystal structures, the fundamental concept, unit cells. Then we're going to move to crystallographic point directions and planes, crystalline and non-crystalline materials. And chapter 4, we're going to see imperfections in solid. We're going to see what we call point defect, miscellaneous imperfections, microscopic examinations. And chapter 5, we're going to talk about diffusion. We're going to learn about what diffusions we are and what we do with diffusions. We're going to see fixed first law, fixed second law, factors that influence diffusions, and all this. And for chapter 6, we're going to see the mechanical properties of metals. We're going to have some learning objectives there, also why we study mechanical properties of metals. We're going to do concept and stress strain, elastic deformations. We have stress strain behaviors. We have an elastic and plastic deformations, properties and variabilities, and design safety factors. All this we're going to talk about here. And chapter 7, you can see it there is dislocations and strengthening mechanisms. We're going to see all the dislocation and strengthening mechanisms, dislocations and plastic deformations in materials. And we're going to talk some basic concepts and mechanisms of strengthening in metals, the recovery, recrystallization, and grain growth. And chapter 8, we're going to study failure. Failure is one of the most important topics in material science and engineering, because as we know, materials tends to fail. There are some cases in which we design materials to fail. So we're going to talk about failure intensively in this course. So we're going to learn about fracture, fatigue, creep, all these things. Then we're going to move in chapter 9. We talk about phase diagrams, and we're going to definitions and the basic concept of phase diagrams, binary phase diagrams, the ion-carbon system, all this, how they are related to material science and engineering. And chapter 10, we're going to continue with phase transformation, development of microstructures and alteration of mechanical properties. Here we can see phase transformation. We're going to see microstructural and property chances in ion-carbon alloys. And for chapter 11, we're going to talk about applications and processing of metal alloys. We're going to see there are the types of metal alloys, fabrication of metals, how we fabricate metals. Okay, and we're also going to see the thermal processing of metals. These are very important topics. We're going to see annealing process, heat treatment of steels, precipitation, hardening. All these are very, very important topics, and we're going to use them extensively in this chapter. And for chapter 12, we're going to see the structures and properties of ceramics. Ceramics is another type of material, so we're going to see that. And this is also a very important ceramic materials. So we're going to look at the atomic structure. So we're going to see the ceramic structure, where we're going to talk about the crystal structures, the silicate ceramics, the carbon, the imperfections in ceramics, and the mechanical properties, why ceramics are brittle, why we're going to look at their stress strain behaviors, their mechanism in plastic deformations. And chapter 13, we're going to see the application and processing of ceramics. We're going to see the types and application of ceramics. Where do we apply ceramics after we study their structure and how we're going to use them. And we're going to see how their types and applications. And we're going to see the fabrication and processing of ceramics, how fabricated ceramics are, processing of glasses, how we can make glass and glass ceramics. We're also going to see the fabrication and processing of clay products, and how we can make this clay product, powdering, pressing, tape casting. All these are methods in which we deal with ceramics. And also we're going to use polymer structures. This is also very important. All like rubber, plastic, all these things are polymers. So we're going to start with the hydrocarbon molecules. Here also there is a little bit of chemistry and the polymer molecules. So we're going to see the chemistry of polymer molecules, the molecular weight, the molecular shapes, molecular structures, molecular configurations, thermoplastic and thermosetting polymers. We're going to see copolymers, polymer crystallinity, polymer crystals, defect in polymers, diffusion in polymeric material. These are all wide topics. These are all subjects on their own, but we're just going to scratch the surface because this is just an introductory course. And chapter 15, we're going to see the characteristics, applications, and processing of polymers. So we're going to see the mechanical behavior of polymers. When we stress strain behavior curve, when we stress a polymer, what will happen? We're going to see the macroscopic deformation. We're going to see what we call viscoelastic deformation, fracture of polymers, and we're going to see mechanisms of deformation and for strengthening of polymers, how we can strengthen polymers. You can see some polymers out there, they are really strong now because we have learned how to engineer this. We study their microstructures, and now we can able to make polymers that are much stronger. We're going to also see the deformation of semicrystalline polymers, factors that influence the mechanical properties of semicrystalline polymers. We're going to see the material of important shrink wrap polymer film. We're going to see that one. This is a fabricated polymer. And deformation of elastomers, we're going to see that also in more details. Like I said, these are very, very wide causes. You can learn a lot about them. Crystallization, melting and glass transition phenomena of polymers. We're going to see the lot. We're going to see the type of polymers, plastic material types. We're going to see elastomers. We're going to see fibers, miscellaneous applications, advanced polymeric materials. We're going to see polymerization, polymer additives, forming techniques for plastic, fabrication of elastomers, fabrication of fibers and films. This is a very extensive topic. Polymers is a whole course on its own. And chapter 16, we're going to see composites. Okay, we're going to talk about particle reinforced composite. We're going to see what composites are. We have this large particle composite, dispersion strengthening. We're also going to talk about fiber reinforced composite, influence of fiber length, influence of fiber optics and orientations and concentration. We're going to see the fiber phase, the matrix phase, polymer matrix composite, and the metal matrix composite, ceramic matrix composite, carbon composite, hybrid composite, processing, and fiber reinforced composite. We're also going to see the structural composite, and we're going to move to chapter 17. We're going to talk about corrosion and degradation of materials, how materials can corrode and degrade. And also we're going to talk about corrosion of ceramic materials, degradation of polymers. We see how swelling and dissolutions affect polymers, the bond rupture, weathering, and all that. We're also gonna see the electrical properties of materials, why some materials conduct electricity, while others don't, while others are insulators, others are good conductors, or others are semiconductors. So we're gonna talk about that intensely in chapter 18. This is going to be very interesting. And so we're gonna talk about electrical conduction, we're gonna talk about Ohm's law, electrical conductivity, electronic and ionic conduction, energy band structures in solids. We're going to talk about conduction in terms of band and atomic bonding models. We're going to talk about semiconductive materials, dielectric materials, and all this. And chapter 19, we're going to talk about thermal properties. And chapter 20, we're talking about magnetic properties. And chapter 21, we're going to talk about optical properties. All these are courses on their own. You can learn a lot about them. And chapter 22, we're going to talk about economic, environmental, and societal issues in material science and engineering, because this is also a very wide topic, and we know that environmental, climate change, all these things are very, very concerned when it comes to materials. So economic considerations, environmental and societal considerations as well. So these are just the topics that we are going to deal with under this section of our lectures under material science and engineering. So we're gonna start with chapter 1 in the next video. Until then, I will say goodbye for now. So subscribe to my channel, and hope you will enjoy the course, material science and engineering. Very good course. It is a course that is all about the world that we are living in, all the materials. We're going to learn the materials and able to use them and manufacture and start to fabricate things on our own. So this is a very important course. Subscribe to my channel and share my videos if you like them, or you can leave a comment below so to improve my videos. Thank you.